Hi friends, I hope all are doing well. So today we'll discuss on design of knuckle joint with application as well as I will take the examples. While designing, first we must understand the use and application of that part or a joint. So let's begin with what is knuckle joint. So knuckle joint is used to connect these two rods which are under the action of a tensile load. So here there are various applications. We'll see the first application that very first which knuckle joint has been used in the tractor and trolley where we are joining it. We can see here. Okay, so it looks just like a single eye and a double eye. This part is called as a single eye and this is double eye. Now, one more application if you see here, it is also used in the bicycle chain to connect the two links. Okay, here also you can observe that this is actually the pin and this both the rods has been connected. Okay. So this is how there are various applications. That is other applications. This is called as a jeep crane, which are used in the material handling, especially in the industries. Here also these two rods has been get connected with the help of knuckle joint. And one more application you can see here. Basically, we are used to join the coaches of the train very easily just by using the knuckle joints. And that's why we can say that from the above applications, we come to know that the knuckle joint mostly used in the mechanical and automobile sector. Okay, when whose axis is in the same plane. Okay, at that time, the knuckle joint is the most usable joint for assemble and disassemble of that two rods. Then the components in the knuckle joint. So first we'll see the single eye. As there is another part is called as a double eye, and double eye is also called as a fork end. You can see here it looks like a fork, no? So that's why we are saying that it's a fork end. Means it's very simple. That means one end of the rod is made up of single eye and the other rod is from a fork end, okay, which is a double eye. And the third part which we are observing is the knuckle pin. And this knuckle pin which passes through the whole of this single eye and the double eye. And it has been properly, I can say, secured by with the help of this collar pin. We can see here also. Okay, and for that we need a split pin. So all these are the very few parts of this knuckle joint. Next, we can see some notation which has been used while designing the knuckle joint. And first, if you see here, I shown the single eye and double eye. And here, the diameter of both the rods are same, right? Means D is the diameter of the rod. Then second part, you can see the knuckle pin. And this knuckle pin is denoted by D1. You can see this is the knuckle pin. Okay. And the knuckle pin, I have written that D1 is equal to D. It means that the diameter of the single and double eye is equal to the diameter of this pin. Same ही रहना चाहिए. Okay. Then you can see the third one notation, that is a D2. And this D2 is nothing but the outer diameter of the single eye and the double eye. You can see here in this. Okay. And that is equal to the 2D. Third notation, you can see the thickness of the eye. I shown here also. Okay, and the thickness of the single eye is given 1.25D. Third, fourth element which can be observed here, that is a T1. So T1 is nothing but the thickness of the double eye. Okay, and that is equal to the 0.75D. One more parameter you can observe here, that is a D3. And this D3 which you are observing, this is nothing but the pin head, right, of that knuckle pin. You can see here, and which is equal to the 1.5D. From this, it is very clear that how the D is important. Okay, so all these will be helpful for the empirical relationship. Okay. Next one, in knuckle joint, whenever there are, as we see some part there, single eye, double eye, okay, knuckle pin, right? It means that various stresses will act on that. And the stresses which act will be a tensile stress, shear stress, okay, shear stress will occur on the pin also, as well as on the single and double eye, okay. Then the crushing will take place between the pin and the single and double eye both, and we need a help of the empirical relation. Now let's go for the step 1, failure of a rod due to the tensile load. Okay. Now in this case, we are applied a load on both the ends W, and D is suppose the diameter of the rod. We have seen in the previous slide, we are considering the diameter of the rod will be a D. And here, when you pull it, the failure occurs. Okay. And the जब ये फेल हो जाता है तो हमारा एरिया क्या दिखता है? पहले आप बात हमको पता है, टेंसाइल स्ट्रेस इज इक्वल टू लोड अपॉन एरिया. ओके, तो जो रेजिस्टिंग एरिया होता है हमारा, ओके, वो एरिया कैसा है? हमारा सर्कुलर है. Okay, and that's why I'm writing the pi by 4 d square. Okay, so from that we can calculate the diameter of the rod, which is very important. Then we'll take one example. Since I have taken that in the exam, it is given the permissible tensile stress is equal to 36 Newton square millimeter. It means that as per the material, this is already given to you. And load, we assume 20 kilonewton, that is equal to 20 into 10 raised to the power 3 Newton. Now we can substitute the values here. Okay, when I substitute the value of a sigma t W, we can find a D, and we are getting the D as a 26.59 mm. That is nearly equal to the 28 mm. We are taking the higher end value. Okay, then the next is the step 2. Failure of a knuckle pin in double shearing. How it is possible? I'll show you practically on the model.
Failure of knuckle pin in shearing, how it takes place, I'll tell you. This is how we are inserting. But for better understanding, what I'll do, I'll remove this one. Okay. Now the shearing will takes place at a two place. One from this position and other from this position, and that's why we can say that it is a this pin will be divided into 3 parts, which is called as a double shearing, and D1 is the diameter of this rod.
Now we have seen that the shear stress, again, it is equal to load upon area. Now tau is equal to load upon area. We can see now how is the resisting area, first of all, right now. So student, here when I'm taking the pin here, we know that the failure has been taken at the 2 positions, right? It means it is a double shear. So 2 into pi by 4 d1 square. As the rod is circular, so naturally the area will be pi by 4 d1 square. D1 means, as I had taken D1 as a diameter of the pin. Now, in this case, we can calculate the D1 of that is a diameter of the knuckle pin. Now, we'll take one example here. Here also, suppose permissible shear stress is 40 Newton per square millimeter, and load is given 20 into 10 raised to power 3 Newton. Now, we are having a formula that, right now, load upon area. And now we substitute the values of these permissible shear stress, that is 40. Load is given. Okay. From that, I calculated the D1. Now, this D1, we are getting the 25.23 mm. And in the empirical relations, I have already told you that the D is equal to D1. और हमने यहाँ लिख दिया, the value of D1 should be kept minimum and equal to the D for a safe design. यानी जो हमारा पहला जो डायमीटर D आया था, उतना ही वैल्यू अगर हम डायरेक्टली ले सकते हैं. Okay, but here in this case we are getting the minimum, means there is no issue. Okay, then the third one, I am showing the 2 things parallelly here. Okay, that is the step 3 and step 4. Okay, failure of single eye in tension across the slot. okay, here, and the failure of fork end in the tension across the slot means here this is a slot, okay, which is a circular. This failure, again I will show you through your practically how it is possible, how the failure takes place under the tensile.
Failure of a single eye in tensile. I'll show you that. Suppose this is a pin which is inserted into this single eye, and now you observe when I pull it, okay, under that it is under the tension, you can see here, so it will get break, okay. So the cross sectional area which are occurring, that is called as a resisting area. This is your resisting area, right? This is resisting area. So how we are getting the resisting area? You can see that T is the thickness, right, of this single eye, and outer diameter. How much is the outer diameter? That is a D2, and inner diameter is D1, and that's why we get a D2 minus D1 into T. Next is a failure of a double eye, that is a fork end under the tensile. Here also suppose this is a pin, and when you pull it, right, see what happens when you pull it, it will get break. You can observe here. Now the resisting area in this case, you can see this is your resisting area, okay. This is the resisting area, you can see here, okay. Now this resisting area means again the outer diameter is same, that is a D2, inner diameter is D1, but change will be only in the thickness, that is a T1. So what we are getting, D2 minus D1 into T1.
Now, first we will see that what are the parameters we required. Now, D1 is the inner diameter of a single eye and double eye. You can see in both the cases, D1 is same, whether it is a single eye or a double eye, both are same. Inner diameters are same. Then why it is D1? You know that diameter of the pin जो होता है, जो इसके अंदर जाता है, okay, मीन्स सिंगल और डबल आई के अंदर हम उसको इंसर्ट करते हैं, तो वो जो डायमीटर रहेगा हमारा इनर डायमीटर जो सिंगल और डबल आई का, इट इज सेम इक्वल टू द डायमीटर ऑफ द पिन. देन D2. अब D2 क्या है हमारे पास? D2 इज द आउटर डायमीटर ऑफ द सिंगल आई एंड डबल आई. यू कैन सी फ्रॉम दिस डायग्राम, दोनों का भी सेम ही है, दैट इज इक्वल टू 2D. थर्ड वन इज द थिकनेस ऑफ दिस सिंगल आई एंड दिस T1 is equal to thickness of the double eye. Then as we have already calculated D, जो हमने already पहले निकाल दिया और हमने बता दिया कि D is nearly equal to the 28, and D हमारे पास empirical relation क्या बताता है? D is equal to D1, and that's why I have taken directly this value. Now my friend, how to calculate this one? We know that tensile, if you see that, okay, before that I will show you that a 2D of this. So from this, you can see that it's two rectangles, no? ये और ये दिख रहा है हमको रेड कलर का, ओके. तो हमारा रेजिस्टिंग एरिया, ओके, तो हमारे पास सबसे पहले रेजिस्टिंग एरिया हमको कैलकुलेट करना होता है. फॉर दैट वी नीड अ डायमेंशंस, ओके. सो दिस इज योर D2, दैट इज द आउटर डायमीटर, आप देख सकते हो यहां से यहां तक, और हमारा जो बीच वाला हिस्सा है दैट विल बी माय D1, ये हमारा D1 है, और ये हमारी ये थिकनेस जो है दैट इज अ T, ओके. नाउ if you go for the failure of the fork end under the tension or a double eye, in that case also you can see that how it is. You can see these, ये जो रेड कलर के दिख रहे here, these are the resisting area जहां से वो टूट गया है, ओके. तो हमको पता है कि इसका जो डायमीटर्स है, दोनों का भी डायमीटर्स हमारे पास सेम है, whether it is a single eye or double eye, दोनों का हमारा डायमीटर्स जो है बेटा आउटर डायमीटर सेम है, एंड here it will be a D1, same, you can see here. Only change will be the thickness of the double eye. यहाँ हमारे पास T था और यहाँ हमारे पास T1 है. अगर we'll see that one by one. Then first we'll go for the how to calculate. We know that tensile stress is equal to load upon area. Now resisting area, how we are calculating? D2 minus D1 into T. That is my resisting area. Okay. So now this resisting area, अब क्या होता है कि अगर हमारा इंड्यूस एरिया जो आप कैलकुलेट करते हैं, ओके, उससे अगर हमारा ज्यादा आ गया परमिसिबल एरिया से, सॉरी परमिसिबल स्ट्रेसेस जो आपको दिया रहता है, if it is greater than that, then your design will be failure. ऐसा हो सकता है. So in that case, you can increase the diameter of this single eye. ये जो है ये आउटर डायमीटर आप बढ़ा सकते हैं. लेकिन कब? अगर आपका इंड्यूस स्ट्रेसेस ज्यादा आ गया तो. Okay, now we'll see that. How? Suppose I'm taking the example. Permissible tensile stress is equal to 36 Newton square millimeter. Okay, which is given to you in the problem. Load is also given. Same. Okay, now I'll substitute the value. That is sigma T is equal to W D2 minus D1 bracket into T. Now, my friend, if you observe that in this case, I need a value of T. तो T मेरे पास कैसा मिल रहा है? 1.25 into D. D is 28. Okay, so I got a T here. तो चलो T का वैल्यू हमको मिल चुका है. Then I want a D2. So D2 is how much it is given? 2D, right? 2D means if I have to put the 2 into 28. That will be of 56. What is the D1? D1 is 28. So students, I have just substituted the value and I got 20.40 Newton square millimeter. Okay, अगर आप ये कंपेयर करेंगे तो आपको पता क्या चल रहा है कि हमारा जो इंड्यूस टेंसाइल स्ट्रेस है जो हमने फाइंड आउट किया ये इससे कम है. इट मींस दैट योर डिजाइन इज सेफ. ओके, नो नीड टू चेंज द आउटर डायमीटर ऑफ दिस आई. देन आई विल गो फॉर द डबल आई. सो हियर आल्सो टेंसाइल स्ट्रेस इज इक्वल टू लोड अपॉन एरिया. तो जैसा मैंने बताया यहाँ वैसे ही अगर यहाँ इंड्यूस अगर हमारे पास इंड्यूस टेंसाइल स्ट्रेस अगर ज्यादा आता है, in that case naturally you have to change the outer diameter of this double eye also. Okay, but we'll see that through the example. Okay, so here also you can see I have taken the tensile stress same 36 Newton square millimeter. Load is also 20 into 10 raised to the power 3. Now see the formula here. When we are talking about the resisting area, तो ये 2 क्यों आ गया? क्योंकि डबल आया है. एक एरिया इसका आएगा, एक एरिया इसका आएगा, तो ये 2 हो गया. बाद में हमारा D2 minus D1, okay, into T1. How much is the thickness? T1 is the thickness. You can see from this diagram also. Now, my friend, I'll put the value. अभी हमारे पास T1 available है क्या? नहीं. So what I will do, my friend? What is the T1? T1 is equal to 0.75 D. So I substitute the value. I got it 21. Okay, means T1 is 21. Now, when I substitute the values, we come to know that I'm getting the 17 Newton per square millimeter. If I compare these both, okay, तो यहाँ क्या हो रहा है हमारा? जो हमारा induced tensile stress जो आपने अभी निकाला है वो कम है than the permissible tensile stress. Means your design is safe. Nothing to worry here. Step 5 is the failure of single eye in shearing. And step 6, again, the failure of a double eye in shearing. Now, to understand this one, how the shearing will take place, I'll show you one application that when you are doing the plowing, right, the land of the surface is uneven, due to which the shearing will take place in the single eye and the double eye both. And I will show you these practically also.
Failure of single eye in shearing. Now you know that when you are inserting a pin inside this hole, but and there is an uneven surface on the land. जैसा हम ट्रैक्टर और ट्रॉली अगर देखते हैं और वो हमारा अगर लैंड के ऊपर मूव हो रहा है तो इट इज अनइवन. And due to that unevenness, what happens? And even there is some error here between the hole and the pin. And due to that reason, you can see the shearing will takes place again like this. So when the shearing takes place, we come to know that the resisting area in the shearing, this is can observe here. D2 minus D1 into T means resisting area in the shearing and resisting area in crushing. In tension, both are same. Okay. Failure of double I in shearing. Here also I am inserting a pin, right? Again it is a loose one, and same concept that when you pull it, okay, now the shearing action will take place here like this. Now here also the resisting area in the shearing as well as in the tensile both are same, means D2 minus D1 into T1.
If you see here in the step 3, that failure of the single eye has taken place in the tension or in the tensile. Now the resisting area here and the resisting area in the shearing both are same. Okay, इसका मतलब resisting area का जो formula रहेगा दोनों का same है, D2 minus D1 into T. So the formula remains the same. There is no change in that. Can see that. So here also what I will take one example here. So resisting area आपको यहाँ पता चल गया. Now one example, permissible shear stress. अब यहाँ कितना लिया हमने 40 Newton per square millimeter, which depends upon the material. And load is 20 into 10 raised to the power 3 Newton. तो हमारे पास formula है tau is equal to load upon area. So students, what all the D2 and D1 already we have calculated. Okay, and directly we substitute the value there. Okay, so 20 into 10 raised to the power 3, which is a W. D2 is 56. We know that 2 into D is 2 into 28 will be a 56 minus 28. T is the thickness which you have calculated 35, and we have got the value ultimately 20.40 Newton per square millimeter. And if you compare the induced and the permissible shear stress, yeah, induced shear stress is less than the permissible. It means that your design is safe. Now, step 6 is the failure of a double I in shearing. I'll show you that the failure which takes place in the tensile or as well as in the shearing, both the areas are same. You can observe from this diagram. Okay. So shearing, again the resisting area which occurs here is D2 minus D1 into T1 into 2. This here, and the resisting area during the tensile stress, both are same. Right now you can observe here, but here in both the cases it should be twice the area. Be careful there. Now if you see here, shear stress is equal to load upon area. Now resisting area, that is twice D2 minus D1 into T1. Then this equation is used to again to check the induced shear stress. अगर induced shear stress हमारा कम है than the permissible, means जो दिया रहता है, in that case the thickness of the plate you have to change it. But we'll just see the example here. Now permissible shear stress is equal to 40 Newton per square millimeter. This is given to you, and load is also given. And then we are having the formula that shear stress load upon area. So we have put the 2 into D2 minus D1 into T. And you can see, student, when I substitute the value, right, of D2, you know that D2 is now 56, right? Then the D1 is 28, right? So, and thickness is 21. This thickness is 21. And multiply by 2. That is the formula we have calculated. Now, what we'll observe here? So, in this case, the induced shear stress which you have calculated is only 17, which is lesser than the permissible shear stress. And that's why I can say that our design is safe. There is no issue in that. Okay. Then the next one, the failure of the single eye in crushing. So here crushing will take place in both single eye and as well as the double eye. Here I'll show you the some practical applications of that, or practically through this model.
Failure of single eye in crushing. See, naturally, we are just when we insert the pin, there will be a somewhat angular rotation, and the crushing action will takes place between the single eye and the pin. At this region, the crushing will takes place. That I will show you here. Here, this is a zone where the crushing will takes place at this region. Okay, so this region is nothing but the D1 into T. So that will be only the crushing area, that is called as a resisting area, that is a D2 into D1 into T. Okay. Now failure of double eye in crushing. Again, I am just inserting it, and we know that here there is a possibility of just making an angular movement, and due to which the crushing action will take place between the pin and the eye, that is a double eye, at this portion. Okay, so this portion is nothing but the, here I am showing that at this region the crushing will take place. Okay, same way the crushing will take place at this position also. Okay, I'll just move like this here also. Okay, this area, and that's why what is this diameter is again a D1, but thickness is T1, means 2 into D1 into T1. That will be given a crushing area for the double eye.
Now, in single eye, T is the thickness, right? And how this, which I have shown in the video, how the crushing area there, and that crushing area which you are observing here, I just shown with this T is the thickness and D1, right, at the middle portion, right? At that time, the diameter is D1. Okay, that is the inner diameter of the single eye. So what is the resisting area in these such cases? That is load upon area. So resisting area is equal to D1 into T. You can see here. Okay. Now, same thing, now why I written that statement. Now, for example, suppose crushing stress, shear stress, we are considering 70 Newton per square millimeter as per the material selection. Then load is given. I'll just substitute the value. So when I substitute the value, D1, we know that D1 is 28, thickness is 35. I have got 20.40 Newton per square millimeter. So if you observe that the induced crushing stress is less than the permissible, so your design is safe. There is no issue here. Now in this in double eye, if you see the crushing, it is again on the inner side. Here I will show you the 2D of this. You can see. Now where is the crushing area? This here, D1. D1 is your crushing area, and T1 is the thickness of that double eye. So here on that particular region, that is called as a resistant area, that will be given as a 2 into D1 into T1. Why it is 2? Because there is a 2I here. Okay, that's why we are multiplied by, because we are getting the 2 area. Now we'll see that example. Same crushing stress, load we are taken. Now we'll find the value. So see, when I substitute the value in the crushing stress, same 2, D1 is 28 and T1 here, T1 is 21. So I substitute the value of 21, I'll get 17 Newton per square millimeter. And here we are again observing that our induced जो आपने निकाला है वो कम है हमारे परमिसिबल क्रशिंग स्ट्रेस से, तो नेचुरली हमारा डिजाइन क्या रहेगा? सेफ रहेगा. Now student, I had just shown the summary here. Now in the first step, you know that the failure of rod due to the tensile load, that is a load upon area. Here the area which are occurring, the failure where takes place is a circular one, and that's why pi by 4 d square. From that we can finding the diameter of the rod, that is d. Second thing, shear stress is equal to again means failure of a knuckle pin in double shearing. So load upon area, this is a formula. Now here in this formula, what we are finding? We are finding the D1, that is the diameter of the knuckle pin. So both the D we have calculated, and even if you don't calculate, we know that the diameter of the rod we should keep, or I can say the diameter of the pin is equal to the diameter of the rod. So even if you don't calculate, but we have to consider the diameter of the rod there. Then if you see here in this region, these are all the empirical relationships. So we have discussed a lot of things on the empirical relationship, which is required to find the other parameters right now. So third step, failure of single eye in the tension, which is across the slot, means where there is a weak part. So naturally वहाँ fail होता था. So that is here in this formula जो आपको दिख रहा है. Here this is the D2 minus D1 into T. Same thing will be the failure, but here what we are finding, we have to just check the induced tensile stress, right? Here also in the double eye, you can see the load upon area, but here 2 into D2 minus D1 is D2 minus D1 into T1. Okay, तो यहाँ भी हमने टेंसाइल स्ट्रेस जो इंड्यूस्ड टेंसाइल स्ट्रेस है वो हमको निकालना है. नाउ फिफ्थ स्टेप, जैसे हमारी फेलियर ऑफ सिंगल आई इन शेयरिंग एंड डबल आई ऑल्सो इन द शेयरिंग, तो हमारे पास फॉर्मूला है लोड अपॉन एरिया. ओके, नाउ W अपॉन here also, see the important thing is that failure of single eye in tension and failure of single eye in shearing, in both the cases the area resisting area are same. ओके, तो हम जब प्रॉब्लम सॉल्व करते हैं तो हमने यहाँ ध्यान देखना चाहिए कि दोनों का वैल्यू सेम ही आना चाहिए, तो समझ लेना हमारा प्रॉब्लम राइट है. ओके, हियर आल्सो यू कैन सी दैट द रेजिस्टिंग एरिया इन बोथ द केसेस आर सेम, टेंशन एज वेल एज इन द शेयरिंग. आप देख रहे हैं राइट, दोनों. तो हमारा जो आप कैलकुलेट करेंगे तो दोनों का वैल्यू भी हमारा सेम आना चाहिए. नेक्स्ट इज द फेलियर ऑफ सिंगल आई इन क्रशिंग. Here also the load upon area. The crushing area is D1 into T. You can see here this one, right? But in the failure of double I in crushing is again load upon area. But here there is, you can see W D2 D1 into T1. But why I'm multiplying by 2? Because there are 2 I here. दो area हमको यहाँ मिलता है. That's why I multiply by 2. And we are getting this. This is a diagram how we are showing that. Okay, so here also we are checking the induced crushing stress for the single and double eye. Thank you, friends.